We and we are just kickstarting a lot of the programs we have in because of some activities that kind of started the year. And this is the very first workshop we'll be having this year. And it's pretty gonna be the one we believe that you should not miss because we brought in somebody that is gonna, show us and teach us and show us the things that is needed to get people into Web3 without stress, without friction, and the whole thing about account abstraction and stuff like that. So I don't want to say so much. I would love to introduce him, but it's better for sometimes to give people the opportunity to introduce themselves because they know themselves more and things like that. So I'm gonna be Rahat. Thank you so much for joining. And these people want to know, would you kindly introduce yourself?
Yeah, definitely. So I guess a quick intro to me. I'm Rahat. I'm a senior developer relations engineer at Morph, and I founder of a little side project I do called Protocol Explorer, where we do like live streams, and going to be starting to do courses there soon as well. So yeah, just like really um, passionate about helping developers upskill in the Web3 space and just start building.
All right, you heard it. So I kind of like when I was trying to reach out to it, right, I mentioned the Protocol Explorer thing because I saw it and I was like, this is something I've been following up behind this thing quietly, just watching. And would you know that I think Idris was on the stream. Was that on today, yesterday, Thursday?
Yeah. Yeah, Idris
Yes.
was on the stream. He was telling us a little bit about Axelar and building a cross-chain apps using that.
Yeah, I caught the stream of that. And it's pretty exciting to see people are being given back and like trying to teach people others. And that's what we're trying to do at Web3 Africa. And hopefully this workshop is one of those things that we hope we drive the value we need to, because account abstraction is something I'm personally interested in, because I feel it's the one way to take away the lot of stress from the users and put that all behind the scenes. So without further ado, I'm gonna leave the stage now and let you do your thing. Thanks so much for coming around, Ryan. Let's go.
Cool. Thank you so much for having me. I'll share my screen and we'll get started. Cool. All right. Thank you all for coming to the talk. Is everything good?
Yeah, it's good.
Okay, cool. All right. Thank you all for coming to my talk. So this is going to be an introduction to account abstraction. What I hope you kind of take away from this workshop is that you kind of like get to dive a little bit deeper into like what makes account abstraction work, so that you can take kind of like the fundamentals of what we go over and start building your own dApps. Cool. So we kind of went over this. I'll just quickly go through this. I'm Rahat, senior DevRel engineer at Morph, co-founder of Protocol Explorer. Previously been like a front-end engineer, freelance Solidity engineer. You can generally find me at Rahat Codes on most platforms or at Rahat on Farcaster and Lens. My DMs are always open if after we go through this workshop, you have any more questions, you want to set up some time to chat, always happy to do that. Cool. So today's focus is going to be around account abstraction, specifically ERC 4337. So 4337 is a standard that is currently used for EVM blockchains for account abstraction. And everything that we go through and dive into is going to be specifically around this subject. First of all, like what exactly is account abstraction? So you can define account abstraction as being the ability to use programmable wallets to add arbitrary verification logic to a transaction. What does that mean? A lot of words there, right? So programmable wallets is like the big part here, right? You have a wallet or an account, and you can, rather than your traditional wallet, which is governed by the ECDSA, which is the signature scheme for accounts. We're going to refer to those as EOAs or externally owned accounts. So EOAs are a little bit, I would say, not as flexible in the way that you can do transactions. versus a programmable wallet or a smart account, which is a wallet or account that is governed by code rather than a specific signature, is going to allow you to program specific types of logic that you may want, right? So that's kind of like at the basic, what we're going to be focusing on today. This concept of a smart account or a smart contract wallet. And these smart contract wallets will be able to use any type of verification logic before doing a transaction. Some of that logic might include things like, should this transaction be sponsored or not? Should this transaction be batched with another one? Both of these two situations are things we're going to look at today. So before we dive any further into it, we kind of defined it, but why exactly do we need account abstraction? If you kind of think about the onboarding experience for regular users, not even devs, forget devs. Us as developers, we're not actually important. What's actually important are customers and users for the applications that we're building. There's not a lot of emphasis right now put on that side of things for Web3. Because if you think about it, if I want to use any type of application on Web3, there's several friction points that I have to go through before I even get started. I have to onboard onto a wallet, figure out what seed phrases are, figure out what they even mean, where I have to put them, figure out how to manage my private keys, figure out how to get some fiat onboarded into my wallet just to get started using any type of dApp. I have to understand what gas fees are. Maybe if I don't want to use a layer one like Ethereum, now I have to learn what exactly a layer two is. Maybe I have to bridge some funds over. Every single one of these things are things that your users and your customers have to do before they even use your application. And that is absolutely insane. Because if you think about it in a regular Web 2 environment, the more the user has to actually get started doing a bunch of other things before they can use your app, the less likely you will make a sale, the less likely you will have a user, the less likely your application will ever be a success. So this is a huge thing that is pulling Web3 back, this insane user experience. So account abstraction is going to allow us to do a few things to remove a lot of those friction points, to make it so that your app can actually have users, you can actually have revenue. Because if your app doesn't have revenue, what's the point? So we're going to discuss this through a practical example. It'll be a fun example, or I think it's fun at least. And we'll kind of look at the experience and how Web3, how the Web3 experience is and how we can enhance the experience using account abstraction. One thing to kind of note here, though, we're going to be focused on just the UX of a transaction. We're not going to be focused at all on UI during this workshop. I've actually completely left any UI components out. We're simply looking at how to improve the UX of doing a transaction. UI and UX are very different things, although they're very much interchanged. But our focus today is not on UI. It's going to be on the UX. So I have two daughters, right? So my daughters, they're very young at the moment. The older one is 3, younger one is a couple months. But at some point, they're going to have to go off to college, right? And I'm probably going to get a text one day saying, Bubba, I need some money. That happens. My 3-year-old has already asked me this, and for toys that she needs. But this is going to happen, right? So they're eventually going to go off to college. They're going to need to have some type of allowance for spending money. And they're probably going to spend too much of that money and need more. And I want to be able to get them that money quickly and easily without having to think about it, right? Now, if we were to do this in the Web 2 sense, there are different apps that already exist, stuff like PayPal, stuff like in the US, we have Cash App and Venmo. So these are apps that can send funds to another person. But what if I wanted to send them stable coins? Maybe we're in a future where stable coins are more widely accepted in places. And so what I want to do is make sure that when I am sending them coins, these stables to use, that I can send them very quickly. I can send them without thinking about them. I don't have to like connect a wallet, transfer, do all this nonsense. I don't have to do all these kind of things, right? I just want to quickly send my daughters some funds, some money. I don't want to have to think about having gas on enough money to pay for gas on my wallet, when all I want to do is just send them some stables. So this is the experience that we're going to be kind of like enhancing today using account abstraction. Doing this with stable coins would suck if we're going to be looking at it from like a current Web3 UX perspective. Because let's say I have a dApp that allows me to transfer ERC20 tokens to my daughters in certain ways. If I were to do that, there's a couple things that happens. I connect my wallet. I have to approve a certain amount of tokens to be transferred and used through this app, and then I have to do the transfer. So that's like what, 3 clicks right there. I have to do all these clicks, find all these wherever this experience exists in the application. And with your UI, you can kind of like, fake it a little bit. But at the end of the day, there are better ways to do this. So first thing we're going to look at is what I call the allowance contract. So there's 2 smart contracts that I've written out before this workshop. We're not going to focus too much on the contracts themselves, but I'll just quickly go through them just so you have an idea of what these contracts do. First is this very basic token. I've called it basic token because I don't know how to name things. All it does is 2 things. When it's deployed, it mints a bunch of tokens, and then there's this mint more function if I ever need more. So this coin is not going to the moon. It is worthless. It is deployed on the Sepolia testnet. Additionally, I have a kids allowance smart contract. This is sort of an unfinished contract. But the main thing here is that I can deposit some ERC20 tokens as a parent, and my kid can request funds and take those out, right? That's really like the basic kind of thing. We're not even going to be interacting with most of these functions. The main things that we're going to be looking at is this deposit function. The single flow that we're going to be optimizing for today is that me as a parent, I want to quickly deposit funds in this contract so that my kids can easily take funds out and use them at a later time. So that's the functionality, contract flow, approval, and deposit tokens. Eventually in the contract, I may want to do things like creating allowance limits for allow listed addresses. This is actually part of a more advanced version of this workshop that I'll be doing later. Allow listed addresses can, withdraw the funds. But the thing that we're going to focus on is here, approving and transferring the tokens. As a father who has little patience for apps that take time out of my day, I'd like to minimize the amount of clicks and transactions that I perceive. I do not want to think about having enough native gas tokens to pay for transaction when my kid has done something dumb and needs some money. So we want to make sure that both of these situations are taken care of during the transaction that we do. So this is the on-chain UX that we're going to be improving. So what actually helps us to do this? I mentioned before, smart accounts, smart contract wallets, kind of like interchangeable in their name, but this is going to be a replacement for your wallet. This is a replacement for your externally owned account. So like I said before, it is governed by code instead of the ECDSA. Smart contracts also have a signer or an owner, which can be an EOA. It can also be a passkey. So whenever you actually do like a transaction with a smart contract wallet or a smart account, there needs to be some type of owner that signs for the transaction on behalf of it. Because a smart contract wallet itself cannot initiate like a transaction on chain. The other cool thing with smart contract accounts is that there are counterfactual addresses. this just means that we know the address of the account before it's even deployed. And this happens with an opcode called create2. Using create2, we can actually gather the address of the smart account. Because it's a smart contract, it needs to be deployed to actually be usable. But we already know what the address is before it's deployed. You can send it funds, you can do anything you need with it. And I'll be demonstrating that later today. So now we know what smart accounts are. We know what wallets are. Let's go on to transactions. So transactions, the way we look at them in account abstraction, they're replaced by something called user ops or user operations. And user operations are pseudo transaction-like objects, and eventually they will become transactions on the EVM. This is just a new way of looking at transactions. So the reason user ops are necessary in this context is because ERC-4237 does not change anything at the protocol level. It is just a new standard on top of the regular protocol. There's no changes to the actual EVM for account abstraction. So we need sort of like a different, more flexible transaction object to be able to do some of the abstraction that we're talking about. So that happens through the user ops. So the chart that the very intimidating chart that you see here are all of the fields that are within a user operation. Now, if you go through it, you'll notice a lot of these things are just exactly the same type of things a regular transaction is going to have, because again, it needs to eventually become a transaction on chain. So many of these fields are going to be the same. There's going to be 3 fields, though, that I want to focus on during this workshop. First is the init code. And this is just code that is used to deploy the account if it's not yet on chain. So you might have like this user operation. It would be, just think of it as like a big giant JSON or a struct if you're looking at it from like a Solidity perspective. And it has some init code. That init code is basically going to exist if this account has not been deployed yet and needs to be deployed. So that code will essentially help the smart contract be deployed during its first transaction. So you can initiate your first transaction, and within that time period, it will also be deployed as well. Next is paymaster and data. We'll go into what a paymaster is in just a second, but this will contain information about where the address of the paymaster and any extra data required for verification and execution. This field is necessary in order to make sure we can do a gasless transaction. If you want to get like further into it, this field can also help you do things like paying for gas in ERC20 tokens, which is something I'll mention, but won't go like too deep into today. And then the signature itself, it's used to validate a user operation along with the nonce during the verification. So during this entire account abstraction process, there's a verification and execution phase. And we'll dive into kind of like how both of those phases work. But first, so you know about smart contract wallets or smart accounts. You know about user operations, which are the new transactions, basically. Now, the infrastructure that helps to actually make all of this work. On the left, you'll see the bundler. So bundler basically bundles user ops and sends them to the entry point. We'll talk about entry point in just a second. Paymaster allows for flexible payment of gas fees for transactions. And when I say flexible payment of gas fees, that means it can be sponsored, which means the end user doesn't have to pay for gas, or it can do something like allowing the end user to pay for gas in ERC20 tokens. So bundlers and paymasters use a combination of both on-chain and off-chain services to actually function throughout this process. Cool. So the last part of this is the entry point contract, which is probably really the most important part of the full flow, because the entry point contract is what connects all of these pieces together. The entry point smart contract is a smart contract, of course, that is deployed one on every chain. It's the power behind 4337. And there's a couple of things here. First, it accepts user ops from a bundle to handle on chain. So on an entry point contract, there is a function called handle ops, which basically a bundler is going to call that function with any user ops that it has to process on chain. The entry point contract will also be the one to handle deploying a smart account. So, like I mentioned here before, we have an init code. If the entry point contract receives a user operation with init code, that means that this specific transaction is associated to an account that has not yet been deployed, and it's going to have to deploy that during this transaction. It validates the user ops signature. It validates to make to see what smart account it came from, and validates any extra paymaster logic. Does it need to actually sponsor this user operation or not? All of that is done here. One thing that is not mentioned here that I probably should have mentioned, the entry point also, once it executes the user operation, it's going to actually take any of like the gas that was given to it from the bundler and refund the bundler any remaining gas. So the bundler will be like compensated for the overhead that it has to take on to put these transactions on chain. So we're going to go into a demo and we're going to code out a couple of things, but here's kind of like how at a high level this is going to work. My smart account is going to create some user ops. So this is going to be the user ops for approving the token allowance and for depositing it into the child's allowance contract. In the background, there's going to be a paymaster and bundler service, and it's going to update the user op to cover gas, and the bundler will call the entry point to handle the user op. The entry point is going to deploy the account and actually execute it on chain. And then finally, the entry point will compensate the bundler for the on-chain interaction. Now, there's a bunch of different tools that you can use to help you do this, and I'm going to mention some of them right now. One is by Economy. They have like a full stack suite of tools for tapping into account abstraction in general. I used to work at Economy, and definitely recommend. It's a great tool if you want to have like the full kind of like stack there. It's very customizable. It can be a little bit more difficult to use because of the level of customization it allows you to do, but it's definitely a very good tool here. Alchemy also has the Alchemy Account Kit, which is a smart contract account kit that taps into their own underlying infra. Pimlico has account abstraction infra. They have the bundler and paymaster services, and they separately build out an SDK on top of VM for generating accounts. StackUp is another option. Account abstraction infra, similar to Pimlico, and they have a SDK called userop.js for constructing user ops. ZeroDev is also a full-featured smart account SDK. It uses Pimlico infrastructure under the hood, and it's got like a very, very easy to use experience. Overall, these are some of the different tools that can help you out, be part of your stack. The parts that I have the most familiarity with are with Economy and ZeroDev. Economy because I used to work there. ZeroDev is because I've used it in a couple of different projects. Today's tool, we're going to be focusing on ZeroDev. I just feel like getting started, they have like sort of the easiest way to like understand and like execute your like first user operations. So let's code. So you're going to get a GitHub repo with the completed code at the end of this. It'll have all of the code that we go through now, as well as a link to the slides, so you can like go through and review the information for yourself if you need. Cool. I've done just a little bit of prep work beforehand. I've imported everything, installed all of the dependencies that I need, but the main dependencies here are going to be the ZeroDev SDK, as well as VM. And I've already imported the APIs for the two contracts that I have. Some of this is just boilerplate code. These are the addresses of the two smart contracts as well. And now we're gonna figure out how we populate this project ID. So when using zero dev, you're going to need to grab a project ID. You can get that from their website. So let's just generate one. Okay, I've generated one beforehand. So to generate one, you would just click new project. Once you're in their dashboard, you can name your project and pick which chain that you want it on. I'm just doing things on ETH Sepolia. Yes, you can see my project ID in full view here. Don't worry, I'm going to delete it afterwards, so you won't be able to use it. Cool. But when you first create this actual this project, what you have to do is actually give it a gas policy. So if you go down to gas policies, you can actually restrict how like the transactions are actually sponsored. There's different project policies, so you can create a policy here, and basically, hold on. Okay, well, I'm sponsoring all transactions apparently now. That's fine. But if you click this button, you can actually add different rate limits. So if there's a specific amount of ETH that you want to sponsor over a certain time limit, you can do that. You can cap like amount of requests per minute or per hour. Maybe there's certain gas prices that you want to have as a maximum. These are all like different things you can configure. And then there's like contract-based policies. You can add a contract here, and then you can like have very specific, like only this function can be called for gasless transactions. But these are all like customizable policies that you can have in here. We're not going to worry too much about that. You just need to have like one basic one. So I just put like sponsor all transactions here, which is fine. Cool. Let me copy the project ID. I'm going to fill that in here. In real life, you probably want to put this in like an environment variable and not just, in full view within your code. In this workshop, it's fine. I don't care. Cool. Next, we're going to generate a brand new private key. So in the README of this repo, there's actually going to be a script. You can copy this. And this will actually just help you generate a random private key within your terminal. So let me generate that. Cool. So here's my terminal. I've copied in that script. This is a private key of a random address. I'm going to populate that in here. And I'm taking this private key to account that comes from VM. And basically, it's going to take this private key and generate the account. Let me console log that out just to make sure that works properly. And let's run this script real quick with node index.js. Cool. So you can see on screen now, here's my signer. Based on this private key, I've got an address here. This is going to be the EOA, or like the basically the owner of my smart account. Cool. So that's the first part there. Let's take care of just like a couple more items to set up our smart account. First thing, we'll create a public client. So create public client just also comes from VM. That's going to be transport, and that's just going to take our bundler RPC. This is not Solidity, so I don't need to do that. Okay. All right. Context switching between JavaScript and Solidity is like really weird sometimes. Cool. Next, I need to create what's called an ECDSA validator. So this is essentially just associating the public client and the signer together. So signer to ECDSA validator comes from zero dev. This is going to help us with you having this EOA be the signer for our smart account. This takes the public client as well as the signer. Cool. Now let's create our actual account. And we're going to say await create kernel account. And that's going to take the public client. It has this plugins. Sudo. And this is just stuff you can grab directly from the documentation. I'm not going into documentation during the workshop, but this is literally copy and pasted from their quick start guide. This is just going to help you with creating your actual account. Create kernel account is also from their SDK. You'll see sometimes, I believe, like their smart accounts, they refer to them as like a kernel account. It's like a specific naming convention that they use. And last thing before we grab the address of the smart account is to have this kernel client created. And that's going to use create kernel account client. It's going to take in the actual account, the chain, which is Sepolia. And this is just the chain ID that was imported from VM. The transport, which like before is just the bundler. It is the bundler, right? Yeah, it's just the bundler. Oh no, in this case, this is the paymaster. So we're actually setting up the paymaster in this case. So bundler was already done up here. Down here, we're doing the paymaster. Cool. Let me actually just copy this over just because I don't want to mess up. And I'll just walk through this. Okay, so the kernel client takes the account, it takes the chain, it takes the bundler here for the transport, and then for the sponsoring the user operation. So this is like under the hood what it would call when it needs to sponsor a user app. That's where it takes the paymaster RPC. And eventually does the sponsor user operation. So the main things to just remember: first, you're creating your public client using this the ECDSA validator to create the account. And then this kernel client is going to help you to configure the paymaster, which is going to be what sponsors the actual transactions and makes them gasless for the end user. When you're doing this on testnet, you don't really have to worry about anything else. This is all you need to do. When you do this on mainnet, though, you need to basically create a paid account and have like a billing setup because paying for transactions costs real money. So that would be something that you would sponsor on mainnet. Cool. So let's actually go ahead and log out the address with all of that configuration done. So all of that so far, again, even up to here is just straight boilerplate code, all from the documentation. I kind of like went through it a little bit, but this is all stuff you can just copy and paste up to this point, straight from the docs. So let's get the account address. So the account address is going to be kernel client dot account dot address. and we'll just console log out my account. And that's going to be the account address. Cool. So let's take a look, make sure that works. Cool. So here's my account. That's the address for my EOA, and this is the address for my smart account. Cool. Now, there's a couple things I'm just going to do really quickly with this to make sure everything works smoothly. Due to the nature of the smart contract that I deployed, it requires that I whitelist a new parent. This is going to be a parent account. So let me very quickly, since we just generated this account from a random private key, I will have to just prove it. So you can see I did it before to make sure it worked. But let's write this confirm. While that's confirming, I also want to send some of these tokens. So I've got some BSC tokens here. I'm going to send that. Let's send it 200. Yeah, that's fine. Cool. And of course, Sepolia is being Sepolia. Let's speed it up. Okay. Should be good now. Let's look up this on Sepolia and see what's up there. Cool. So actually, just to verify that it has the balance of, so again, this is an undeployed contract, but it's got our balance of the BSC tokens that I just sent it. Okay. Cool. So now we're all set up. Now me as a parent, I have these BSC tokens. My kid needs to actually receive these tokens. I have a brand new fresh wallet, no funds, no gas, nothing on it, right? So I want to make sure that I can still send them these tokens that I do have. So how do we actually start a transaction? I'm going to add a console log here, just like when we do the transaction, just so we see it's happening. So transacting, and here we'll do the transaction. So we'll say const transaction hash equals await kernel client dot send transaction. So send very basic, very simple. There's two ways to use the kernel client. You can do send transaction. You can also, I believe there's like a send user op or create user op, something like that, where if you want like more control over like how the user op is constructed, you can do it that way. We're going to stick to send transaction because it takes care of constructing the user op for you under the hood. And we don't need to worry about that. Because imagine constructing that gigantic object that we talked about before. Cool. So this is going to take what's called transactions. So transactions is just going to be an array. So an array can take multiple items, basic JavaScript. But here, the cool thing is this transactions array can take multiple user operations. So if you recall, for this specific action, I need to approve a certain amount of ERC20 tokens, and then I need to do the transfer, right? Normally in real life, this is 2 transactions. I'd have to do 2 clicks on the front end to actually achieve this. I can reduce that down to 1 click by constructing all of my user ops and passing them into this array. So inside of this transaction array, let's first construct the approval user op. It's going to be 2. It's going to go to the token address, which I saved up here. It takes a value. There's no value here. We don't need to pass any value. So I'll just do big int 0. And then it needs to take some data. So that data will take this encode function data functionality, and the encode function data comes straight from VM. So this is how you encode data for building out transactions. So this encode function data is going to take three things. First, the ABI. So this is going to be the token ABI, the function name, and this is just going to be approve. So this is just standard ERC20 approve. And for args, it takes two arguments. First, the owner address. So that's going to be kids allowance. The spender address, kids allowance address, and then an amount. So we'll have to parse ether, which is another helper function that comes from VM. And how much should I give my kid? We'll give them 50 tokens. Hopefully, if you have kids or have kids one day, you're like a lot nicer to them than I am. Cool. So this is going to handle, approving 50 tokens for a specific transaction. One thing that you kind of like keep in mind here, I'm approving this in this transaction, right? I only have to approve the exact amount that I'm going to send, right? This is like another friction point you can take away from like an end user having to think about this. Because like if you think about like different DeFi protocols that you interact with, anything that requires interacting with ERC20 tokens, you always have to think about, okay, how many tokens am I going to approve? Am I just going to do the max? Please never do the max. And if this is a protocol or some type of dApp that gets wrecked at some point in the future, if they didn't take security too seriously, there's some issues in the smart contract code. You're kind of like exposing yourself to have this huge allowance for an app to be able to transact and take a bunch of your tokens. Never do that. Please never do that. With this, because we can do like an approve and transfer event within one transaction, we can remove the need for the end user to even think about that, and just like always only approve the exact amount that they need per transaction. It's a little bit safer for the end user, and they just also don't even have to think about it for themselves. So we approved, and we'll also do the transfer. So for doing the transfer, the 2 is going to be for the kids allowance address. The value will also just be 0 because we're sending tokens instead of ETH. Hopefully the tokens are worth something. And then again, the data. So it'll be very much similar encode function data. And this, if you want to learn more about how to like use this encode function data functionality, that's in the VM docs. So that's specific to VM. So kernel is built around VM. So if you're familiar with VM, a lot of the ways to do transactions in the kernel client should be very familiar. Cool. This is going to take the kids allowance ABI. The function name for this, I believe, I named it deposit. And parse ether, we'll do, I don't know, we'll just do 10, make sure that works. Cool. So very quickly, again, what I've done here, I've constructed 2 transactions. These 2 transactions have been passed into the send transaction function. They've been passed into this array so that for the action of just like one transaction, I got 2 of them in one go. So again, we're improving on-chain UX this way. I don't have to click twice if I'm doing this on the front end. This would just be a one-click seamless experience. Imagine like kind of taking this and like I used like the DeFi protocol example before. What if you can add this into like a DeFi protocol where you can do like one click approve, transfer, add liquidity to a pool, do some type of like yield farming, lending. Like this is a very basic example, but the principles is what you're supposed should be taking from it. Like the power of like batching transactions and what you can do and like to make DeFi easier to use is like super cool. Cool. And the last thing we're going to do is just console log the transaction hash. And if I did everything correctly, we should see a transaction hash. I hope I did everything correctly. Okay. I did something incorrectly. Uh, let's see. Missing a 2 address. Who's missing a 2 address? You both have 2 addresses. Hmm. Addresses are here. Let's see. All right. Not 100% sure what I'm missing, but let me just copy this over. What changed? Did anything change? Kids allowance address. Was that not there before? No, that's there. Kids allowance address. Here's the two. Did I not? I may have missed like a. Oh, oops. Let's do this. I'm going to copy over the main. This is the perils of live coding. I never recommend doing live coding, but I always do it myself, even though I know what happens. I see no difference between this and what I already wrote. So I probably just missed a bracket or something. All right, let's try it now. Okay. Okay. There we go. I missed a bracket or something somewhere in there. But cool. The transaction is now happening. The moment of truth. All right. We have a transaction hash. Looks promising this time. Let's take a look at what happened during this transaction. All right. So we can see that I was able to send funds from the base 10 basic tokens from this address to this address. I had no gas. nothing, no balance was on this address whatsoever. You saw I generated this address live for you all. Let's take a look at the different logs that came up during this. So with kernel accounts, they like and smart accounts in general, they have an owner, right? So this log is basically showing that the old owner was switched to a new one, and that's basically just my new EOA. And we have this deploy, these two deploy events. So if you recall, I mentioned smart accounts need to be deployed when they're first used. So this was the first ever transaction for this smart account, so it needed to be deployed. So this was done from the actual entry point contract. The entry point contract calls a factory, which that factory handles deploying new smart contracts. Next was the actual approval. After the approval was the transfer value here. And then you'll see like a user operation event, which shows you like how much gas, whether it was successful, and all of that information regarding this. So this is a full kind of like transaction powered by account abstraction, right? So let's just quickly go over again what happened in that flow to just get a better picture. I used an EOA to help my smart account generate a user operation. The user operation was generated for the approval and for the transfer, and it's signed by my EOA. My SDK then requested sponsorship from the paymaster. So under the hood, this is not something that we consciously needed to do because we set up our kernel client to have like the paymaster. The SDK took care of making a request to the paymaster to take our user operation. At this point, the user operation does not have the paymaster in data field. It only has it once we get to this step. Once it makes the request to the paymaster and the paymaster helps to add that paymaster in data field to the actual user operation. So now we know that this user operation needs to be sponsored. This can be skipped. If you skip this step, that means the end user has to pay for their own gas or figure it out themselves. The SDK will then take the user op and make a JSON RPC request to a bundler client. And that handles an inclusion into an alternative mempool. So this is not like the regular mempool for transactions. This is a special mempool specifically for user operations. The bundler service takes a look at the mempool and will bundle together different user operations to actually send to the entry point contract. From the entry point contract, we go to the validation phase. Entry point will validate the user op with the smart account. It'll validate the user op with the paymaster. It'll check if there's any init code. In this case, because this is the first time we ever use this smart account, it did have init code, which means a deployment needs to happen. So again, this step doesn't happen on subsequent transactions. This is just for this time. And then finally, the approval and transfer actually happen. So these are all the steps that are happening in the background to facilitate an account abstraction transaction, right? So like I said, some of these are skippable. You can also add additional steps. Maybe there's additional validation you add on the paymaster for specific addresses. Like I mentioned, when you go to the zero dev dashboard, you can adjust like for more roles. So those are all specific things that could be looked at as well. Both zero dev and Biconomy also have modules that you can add into your smart account. So using those modules, you can add even more arbitrary verification logic. So that allows you to unlock even more things like maybe adding a kill switch for specific addresses. Maybe you get compromised, but you have some type of kill switch to prevent any further transactions from even being used from that smart account. Because it's governed by code, you can add these different bits of logic. And it would just like fit into this specific life cycle. But yeah, that is kind of like the overall overview of account abstraction. This is a very, very basic kind of flow, really just designed to like take you through the steps. Hopefully, like you can now understand kind of like what the underlying architecture does and allows you to do through the transaction, and take that and apply it to, other projects. Um, some other ways that you could even improve this UX. Now we go into like the front end side of things, of like in this case, I just generated a random private key for an EOA, but think of like other ways to generate EOAs. Their services like Privy, Dynamic Magic, they help you to generate EOAs using emails, social logins. So rather than having like a regular Connect wallet, imagine generating an EOA from one of these services and using that as like the owner for your smart account. Now you're removing another friction point, because now your end user doesn't even have to think about wallets. They can think about just using existing sign-on services that they already know about. Um, and like from there, you just like, look at like what are the different types of UX that is relevant for your user base, and just make it as easy as possible for them to just start using your app. So that would be kind of like the conclusion of there. So if you have any questions, I'm happy to take those in the chat. Cool. And I see, yeah, thank you, Kohar, for dropping the code in the slides. Yeah, feel free, guys, to, dive into the code, check it out some more. And like I mentioned, my DMs are always open too. So if you're not comfortable asking questions now, you can always ask them later too.
Yeah, thank you, Rahat. So if you have questions, remember to you can drop it in the chat, or you could just request for the mic and just say them. Me, I would ask a question. Can you like show examples of applications or dApps out there that currently use account abstraction in some form?
Yeah. So there was this really cool chess game that was recently put out. So it's like actually, I think like chess like on chain. Um, I don't remember exactly what it was called, but that uses Biconomy as like for the smart account and like the AA side of things. And the cool thing there is like it uses one of Biconomy's features called session keys, where like generally when every time you do like an on-chain transaction, right, you have to sign again and again and again. Imagine doing that in a chess game. That's gonna suck. So what they did in that case was like they combined, not only the gas lists and the side of things, but also session keys where you sign once and then every time you click, you just do a regular click and like the game plays. You don't have to like sign your wallet again to do that transaction. So like those are like additional cool things that you can do. Um, there's a recent app that came out. I think it's called like Dracula app. Um, it's like it's basically like TikTok on chain. It's built like on top of Farcaster, as well as using smart accounts and account abstraction there. So like that's another one where like in Web3 social, people come in, they don't want to have to think about, you know, um, paying for gas for transactions and onboarding into a wallet and stuff. So that's another cool example, I think, where AA is like live in use.
Yeah, sorry. Thank you so much. So there's another question here, and it says, you can check the chat. Is it only Paymaster and Bundler that account abstraction offers, or those are just the most important use cases?
Um, so the Paymaster and Bundler are two underlying like infrastructure pieces for account abstraction. Um, so like I mentioned before, like at the core, those are going to be very important for like all transactions. You want to make sure that the bundlers is the more important piece, The bundler is not optional. The bundler is what's going to actually push your user operations into the mempool and eventually send it to the entry point contract. The paymaster is actually optional. You can use one, you don't have to use one. But otherwise, like I mentioned, there are like modules that you can add to your smart account. And those modules can be like completely customized and built by you. Um, like I mentioned, account abstraction is like defined as like arbitrary logic, being able to be put on chain. So like the logic that goes into those modules are completely up to you, on like what kind of experiences that you would want to like build out. Those are just like, I guess, stuff that AA offers out of the hood, like, from the get-go, but you can add additional services on top.
Awesome. So that was on lineages. So does that answer your question? Do you feel like you need to ask a further question to that? You can always drop it in chat. So there's another one saying, also when transactions are bundled, is there a way to show users what they are actually doing for just one click? That's interesting.
Yeah, I mean that's really a UI thing. So you can so when in the code, what I was doing was like I constructed the two user ops, right? You can show the user like, hey, these are the two actions that are being constructed. So that like when they do that one click, maybe you show them a pop-up or something that shows like this is what is being constructed based on like what you built from the user op.
Okay. All right. So it's just UI front end stuff.
Yeah.
All right, good. So Compounded is saying, can you explain Alchemy account kits briefly? Like how will you explain it?
Yeah. So account kit essentially does a lot of the same things that the kernel client did when we were going through the code. So the kernel client handled like creating the smart account, sending the transaction. Alchemy's account kit, operates very similarly. It lets you create your smart accounts, generate your user ops, send the user ops to like a bundler and paymaster and all that, using like their infra. Um, I haven't used it personally myself. I just kind of have a general overview of it. I've gone through some of the docs, but there may be a future Protocol Explorer episode where Alchemy comes to teach about that.
Okay, awesome, awesome, awesome. So okay, so there's one more question from Toy saying, if I try to use another EOA to create transactions to the Smart account, will it work?
If it's to like the same smart, so like let's say the smart account that I generated today, it can only be signed by that specific EOA. So during like the validation phase, when a user op is sent to the entry point contract, it's going to check the signature. And the signature for the transaction has to match, like the address of the EOA has to match the owner specified on the smart account. So if you attempt to do a transaction and sign it from like a different EOA, um, the entry point will not allow that transaction to go through because the smart account specifically checks for the correct EOA.
Okay, all right. So I hope that just gives you clarity on that question. All right, so we are we just reached 6:09, so I don't think we should push this any further. So, where can people find you online? If you could just drop like your Twitter, your stuff in the
Yeah.
chat, that would be helpful because I believe that more people would need to maybe get more clarity for questions they couldn't ask in this space. So that is right at Twitter, and if you are in some Discord groups, you might see Web3 Discord groups. You might see them there. You could just tag him and say, "Hey, we're at you take the bar account abstraction. Can you answer this for me, please?" So that should help. So that is account abstraction. And we just looked at the getting started. This should be live on YouTube. Let's say today, tomorrow, next the day after tomorrow. Yeah. So our YouTube page is, yeah, let me just pull that in the chat. So you can go subscribe or check it out. Brian, please can you also drop your YouTube? I think that's where the
Yep.
Protocol Explorers are hosted. Yeah, so Protocol Explorer is the series that Rahat is currently running. Just bring in people to talk about the protocols and just check out things. It's pretty interesting. We had like one of the founders of Web3 Afrika live there a day, 2 days ago, and it was pretty fun when I came in briefly and I saw them having fun. So you could just go check it out, and that is gonna be uh the big part of this, and super exciting to see that we just concluded our first workshop, and hopefully we're gonna have more interesting ones like this. I want to say thank you to everybody for coming around. The slides is gonna be sent if you registered. We're gonna make a mail and send out to you in case you could not get that, but it's also in the chat if you still want to grab it. And the best way to make sure this thing sticks is to go back and just review the notes, and just take it one more time, take your time to just see, because the goal is to get more people on board this decentralized train, and account abstraction is one of the ways that could make that happen. With all the there's so many things in Web3, we just get a lot of the stress of the user and just make them enter. So thank you so much for coming around, and we'll look forward to our next stream. Thank you so much for it. I really appreciate everybody. And on that note, I'm gonna say enjoy the rest of your day, your night, wherever you're streaming from, and see you in the next one. Bye, everybody.
Thank you, everyone.
Yeah.